So here's a summary of group 1. Did you notice that all of these ones that we did had an x squared on top and an x on the bottom? So we have the degree on the top being 2. This is a degree of 2. And this is a degree of 1. And the characteristics that we got from this graph was one of two things. Sometimes we got a hole in our graph, and sometimes we had a vertical asymptote. And with those vertical asymptotes, when we did have a vertical asymptote, we're also going to find that we have an oblique asymptote, and I'm going to explain what that is in a second. So now that we've got all these graphs, one of the things we're going to try and figure out is when is there a hole, and how can we tell there's a hole? What do the ones with the hole have in common? And when is there a vertical asymptote, and how we can tell there's a vertical asymptote, and what does it mean by an oblique asymptote? And we can tell by that equation. We can tell by the equation. So the first one has a hole. We can see it there. One of the things we're going to need to do is label that hole. We know that that hole happens when x is minus 1 because that's our non-permissible value. So the hole's going to happen at minus 1. We just need to figure out what the y-coordinate is. So looking at this equation, what can we do to that equation? Could you simplify it?
Yes.
Okay. So we've got, we could put, well, if we put negative 1 in for the x value, on the bottom we'll still have divide by 0, and that's going to cause a problem.
Factor it out to x plus 1 and x minus
So the top,
1. Bottom and top.
so you can factor out the top to x plus 1, x minus 1. And now since these factors are identical, oops, there's a plus 1 on the bottom. Since these factors are identical, they would cancel out. Then you just get y equals x minus 1. What kind of graph is y equals x minus 1? Y equals mx plus b, a line. That's what our graph was in the end. It was a line. And it's almost perfectly a line, except there's a hole in the graph, and the hole happens when x is minus 1. Can you see, after you simplify, now you could plug in minus 1. Minus 1 would be minus 2. So we're going to find out if you can simplify so that your thing that you're dividing by goes away. Anytime that happens, you're going to get a hole in your graph. So let's look at the other ones that have holes. Can you factor the top of this one? Well, obviously, because it has a hole, you can. And it's going to be x and plus 2 and minus 1. These would simplify. We know that this hole happens when x is minus 2. What's the y-coordinate going to be? Because this one simplifies to y equals x minus 1. Wow, that's the ugliest one ever. And if you plugged in minus 2, you would get minus 3. So that would be the hole in that graph. And you can see that this line, x minus 1, sure enough, the y-intercept is minus 1, the slope is 1. That actually is going to be easy to graph, because we're going to have to graph these by hand. So if we can simplify it to be a line, we can graph that line. And then it's not going to be hard to put in the hole, because that's a non-permissible value, and then you just have to plug that value in to find the hole. There's one more with a hole. I can factor out a common factor of 2x. So I know my hole is going to be when x is 2. And now that it's simplified to y equals 2x, if I plug in 2, I'd get 2 comma 4. So if things factor and simplify, and the thing on the bottom goes away, then you're going to get a hole in your graph. If it factors and doesn't simplify or can't be factored, like you see in these other two graphs, then you will have to still have an asymptote there. And these ones also have an oblique asymptote, which is a diagonal line that is an asymptote. And we'll figure out how to graph those ones after. So that's group 1. Now I'll get you to do group 2.